I'm going to demonstrate how to use an interactive simulation that shows a pressure temperature diagram for water and allows us to look at phase changes on the diagram at either a constant pressure or constant temperature. The link to the simulation is given here in blue, and then I'm showing a snapshot of the simulation. So this is log of pressure versus temperature, and we're showing the critical point here. Bar graph shows for this black dot how much liquid and how much vapor for a certain amount of heat added. And we can look at different processes. So let's go to the simulation so we can better understand its behavior. So here we're looking at the simulation. The black dot's in the solid region, so we have 1 mole of solid, no liquid, no vapor present. And if I pick, let's first look at isobaric, and let's look at melting. So we have the solid phase. If we add heat, of course, until we get to the phase barrier where we have 2 phases present, we had all solid. Now as we add heat, we start to create more and more liquid, and the solid decreases until eventually we're in the liquid region. We only have liquid present. The simulation allows us to just look at one process at a time. So for example, instead of isobaric, I can look at isothermal. And in this case, we're looking again at melting, but because, and let's look at this, where the diagram, what we've done is blow up this region, change the scale, very narrow temperature range in order to be able to see. The point is slightly above where 2 phases exist. And then if I change and decrease the volume, I'll get to the point where we start to make, as we're increasing the pressure, we start to make liquid, because for water, as we raise pressure, solid converts to liquid. And notice is over a very narrow range on the scale. Since this line is almost vertical, we broaden it out in order to be able to see it, and then we're in the all liquid region. So we can pick sublimation, melting, vaporization, or the triple point. The triple point then is where we can have all 3 phases present. The phase rule then at the triple point demonstrates this. The details explain the phase rule and the equations that we used. The idea of this simulation is to help us understand properties of a single component, in this case water, as we vary, either adding heat or changing the volume. And we go through a phase transition from liquid to vapor, or from solid to liquid, solid to vapor, sublimation. Hopefully this makes it a little easier to understand these diagrams and the processes that take place.